When selecting a fuse for a suction pump rated at 16 amps at 230 volts, especially when the documentation is missing, there are several important steps to follow. Firstly, determine the starting current. Since the pump's documentation is missing, it's not possible to obtain an exact starting current value. However, as a general guideline, a motor's starting current can be 5 to 7 times its running current. Secondly, calculate the running current. The pump's rating of 16 amps at 230 volts indicates its running current, which in this case is 16 amps. Thirdly, choose a fuse. Based on the estimated starting current and the known running current, select a fuse that provides adequate protection without tripping during normal operation. For a 16 amp running current, a fuse rated at 20 to 25 amps would be appropriate. Fourthly, consider the wire size. Number 12 wire is generally sufficient to handle the pump's current draw, assuming the run is not excessively long. Now let's discuss voltage hookup and verification. Firstly, verify the voltage. When the installer claims the pump runs on 230 volts, it's crucial to independently verify this. Use a multimeter to measure the voltage at the electrical panel and at the pump's terminals. If the voltage is not within plus or minus 10% of 230 volts, do not connect the pump. Secondly, understand the wire color code. In a typical 230 volt residential installation, the white wire is often neutral, the black wire is hot, which is phase A, and the green wire is ground. However, it's always best to double check the wiring diagram or consult an electrician to confirm the proper connections. Thirdly, connect the pump. Connect the black wire to the pump's phasor terminal, the white wire to the pump's neutral terminal, and the green wire to the pump's ground terminal. Always exercise caution. Verify the voltage and wiring connections carefully before energizing the pump. Improper connections can damage the pump or create a hazardous situation. The fuse selection process begins with understanding the motor's characteristics. Motors draw significantly higher current during startup compared to their normal running current. This inrush current, also known as the locked rotor current, can be 5 to 7 times the full load amps, or FLOT, rating. Selecting a fuse that can withstand this temporary surge is essential to prevent nuisance tripping, while still providing adequate protection against sustained overloads and short circuits. Time delay fuses, also known as dual element fuses, are often recommended for motor circuits because they can tolerate short-term overloads without blowing. These fuses have a built-in delay that allows them to pass the inrush current but will trip quickly under sustained overload conditions. When selecting a fuse, refer to the motor's nameplate for the FLA rating. Multiply this value by a suitable factor, typically 1.25 to 1.75, depending on the type of motor and application, to determine the appropriate fuse size. Consult the National Electrical Code, or NEC, for specific fuse sizing requirements based on the motor's horsepower and voltage. The NEC provides tables and guidelines for motor circuit protection, including fuse sizing and wire gauge requirements. For example, NEC Table 430.52 provides guidance on maximum fuse sizes for different types of motors. Consider the ambient temperature in which the motor and fuses are located. High ambient temperatures can affect the fuse's current carrying capacity, potentially causing it to trip prematurely. If the ambient temperature exceeds the fuse's rated temperature, dare the fuse accordingly. Fuse manufacturers provide darting factors for their products. Additionally, verify the interrupting rating of the fuse. The interrupting rating is the maximum fault current that the fuse can safely interrupt without failing. Ensure that the fuse's interrupting rating is sufficient for the available fault current at the installation location. The available fault current can be determined through a short circuit study. When choosing a fuse, consider the voltage rating. The fuse's voltage rating must be equal to or greater than the circuit voltage. Using a fuse with a lower voltage rating can result in the fuse failing to clear a fault properly, potentially causing equipment damage or fire. Always use fuses that are specifically designed for motor protection. These fuses are designed to withstand the stresses of motor starting and running conditions. General-purpose fuses may not provide adequate protection for motor circuits and can fail prematurely. Consider the fuse holder or fuse block in which the fuse will be installed. Ensure that the fuse holder is properly rated for the voltage and current of the circuit. Use fuse holders that are designed to provide a secure and reliable connection to the fuse. Check for any signs of corrosion or damage on the fuse holder and replace it if necessary. Proper installation of the fuse is critical for its performance. Ensure that the fuse is fully seated in the fuse holder and that the connections are tight. Loose connections can cause excessive heat buildup and lead to premature fuse failure. Regularly inspect fuses for signs of damage or deterioration. Look for cracks, discoloration, or other signs of wear. Replace any fuses that appear to be damaged or are suspected of being faulty. Keep spare fuses on hand for quick replacement. This will minimize downtime in the event of a fuse blowing. Store spare fuses in a dry, protected location to prevent corrosion and damage. Label each fuse holder with the fuse size and type. This will help to ensure that the correct fuse is installed when replacement is necessary. Use a permanent marker or label maker to create clear and legible labels. When replacing a fuse, always disconnect power to the circuit before removing the old fuse and installing the new one. This will prevent electrical shock and potential injury. Use insulated tools when working with electrical circuits. Follow lockout-tagout procedures to ensure that the circuit remains de-energized while work is being performed. Consult with a qualified electrician if you are unsure about any aspect of fuse selection or installation. An electrician can assess the specific requirements of your application and recommend the appropriate fuse and wiring configuration. They can also perform electrical safety inspections and ensure that your electrical system meets all applicable codes and standards. Regularly inspect electrical panels and fuse boxes for signs of overheating or damage. Look for discoloration, burning smells, or loose connections. Address any issues promptly to prevent electrical hazards. Consider using circuit breakers instead of fuses in some applications. Circuit breakers offer the advantage of being resettable, which can save time and money in the event of a temporary overload. However, circuit breakers also have limitations and may not be suitable for all motor protection applications. Compare the performance characteristics of fuses and circuit breakers to determine which is best for your needs. Use appropriate personal protective equipment, or PPE, when working with electrical circuits. This may include safety glasses, gloves, and insulated clothing. Follow all safety procedures and guidelines to minimize the risk of electrical shock or injury. Document the fuse selection process, including the calculations, assumptions, and code references used. This documentation will be helpful for future reference and can be used to justify the fuse selection to inspectors or other stakeholders. Keep the documentation in a safe and accessible location. Educate yourself about electrical safety and best practices. Attend training courses, read industry publications, and stay up to date on the latest codes and standards. This will help you to make informed decisions about electrical safety and prevent accidents. We remember that electrical work can be dangerous if not performed properly. Always exercise caution and consult with a qualified electrician if you have any doubts or concerns. By following these guidelines, you can select the appropriate fuse for your motor circuit and ensure its safe and reliable operation. This includes the proper verification of voltage hookup. Regarding the voltage hookup, since the installer claims the pump runs on 230 volts, you should independently verify this using a multimeter to measure the voltage of the electrical panel under the pump's terminals before connecting the pump. If the voltage is not within plus or minus 10% of 230 volts, do not connect the pump. In a typical 230 volt residential installation, the white wire is neutral, the black wire is hot, which is phase A, and the green wire is ground. However, it's always best to double check the wiring diagram or consult an electrician to confirm the proper connections. Finally, connect the black wire to the pump's phase terminal, the white wire to the pump's neutral terminal, and the green wire to the pump's ground terminal.